All right. Um, as I mentioned last time, in class Wednesday, Dr. Tian will be substituting. I currently have like homework slated is being due that day, but therefore in effect it's due the following day, like slid under my door. Here's a bonus for you. I am returning on Thursday, but I won't be around in the morning, so it could be turned in almost any time that day, and I won't know the difference. And I think it'll be interesting to see how big a pile gets if every single one of you slides it under my door. We'll be all fit. So don't turn it into Dr. Tian. She's going to be like, I don't know what to do with this. I should mention from when I had her substitute in this class 4 years ago, she assigned some problems. I kind of went rogue on me there. So if she does that, just ignore it. It might be good for practice, though. And who knows, I might happen to assign some of the same problems. Because we're still dealing with real roots today, and then she will cover the case of complex roots, and then later I'll do repeated real roots. Okay, and in the interest of getting assignments out there, here is the next one. That's not due until the Monday after next, March 6th. I may push these back. I'll re-examine the due dates and let you know. Make sure we get in certain number of assignments in before the next test, which is still not for a while. The next test is April 3rd. I thought April Fool's Day would be in bad taste. Now, another thing is, okay, so I apologize for not having any more assignments graded yet. There's still sets 4 and 5. This conference coming up is going to be busy because I'm responsible for 8 presentations. 3 by me and 5 by my students. So what I will do is, before I leave this weekend, I will gather up any scrap of paper in my office that even looks like an assignment and take it with me so that I can have all of them back to you when I'm back in class in a week. So get all caught up. Okay. Now, so this is my latest active learning exercise for you. It's going to be a little different than the previous test simulations. That there's not going to be anything for you guys to turn in, but it is intended to help build your speed in solving these problems. That'll be helpful for a test. So I'm taking a big risk here because I've mentioned how one's IQ plunges when they're up in front of the class teaching, but I'll take my chances. So here I have an incompletely specified initial value problem. So we have the DE, and if I were to start solving it, we'd have a characteristic equation: r squared minus 2r minus 8 is equal to 0, and this one is going to factor nicely. So r minus 2 and r plus 4. No, told you. All right. And if I wanted to be completely disingenuous, I'd say I was doing it intentionally to see if you were paying attention. But no, I really did mess up. Oh, yeah, because I remember here's what the roots are supposed to be. All right. So that means our general solution is some constant e to the 4t plus another constant e to the minus 2t. Okay, so what I'd like someone to do is give me a number for initial condition. So y of 0 equals what? Just someone? 2. All right. And y prime is 0? Okay. You guys have such imagination. Okay. So in that case, what we have is so the solution that satisfies the initial conditions is y of t is equal to, and we're going to do a little arithmetic in my head here. 5, 6 e to the 4t plus, okay, so 76 e to the minus 2t. All right. And what we will find is if you were to check, plug in initial conditions, plug in t equals 0, take a derivative and set t equals 0.
So where did you get that from?
You're about this is the point of this exercise, actually. So right now, it's a mystery as to how I could do that. It's not a magic trick. And the point of this exercise is to get you to see how I'm able to do that. And the thing is, I'm not doing this to show off or anything. The point is to get you guys closer to this point, because I think there's a tendency to, it doesn't matter what kind of class it is, what the subject is, that the students had to see the professor as okay, on some other plane. That's not really true. I'm basically a really well-trained dancing monkey, whose job is doing this sort of thing all day long, every day, for longer than you've been alive. So I kind of ought to be good at it, or it's really pathetic. And the same would apply in whatever field you're going into. And so the idea is that kind of practice. The idea is for you to be that good at whatever it is that you're doing, whether you're a math major or majoring in something else. So here's what we're going to do, and we're going to use these two problems as sort of a testing ground for you to figure out where these numbers come about. So first, what I'd like to have you do. So I'm going to have you do this first part individually, and then, actually, to save time, because for a second part, I want you to pair with somebody. So choose who you're going to partner with now. All right. Okay. If the numbers don't work out nicely, then 3 is fine. Okay. In some cases, it's more obvious than others based on seating. Because, so what I'm going to do is, I want one of you in the group to work with this problem, and the other to work with this problem. And what I'd like you to do is solve this problem, or whichever problem you choose, with these initial conditions. So first, y of 0 is 0, and then y prime of 0 equals 1. And then the second set of initial conditions, opposite. Y 0 equals 1, y prime of 0 equals 0. Okay, so this applies to whichever one of these you choose to do. So I don't want to say too much time, but just go ahead and pick your problem. And first you come up. So here are the steps. And your characteristic equation based on your coefficients. You get your roots, R1 and R2. Then your general solution is constant e to the R1t plus constant e to the R2t. Though it doesn't really matter, I would recommend, just to make formulas work out more nicely, choose R1 to be the greater of the two. And then you solve for C1 and C2 using the given initial conditions. Okay, so I'm going to be checking on your progress as you go, so go to it. Okay. All right, so for now, you're just doing this individually in whichever problem you chose. Okay. pause recording because this will get really boring for whoever's watching at home. Okay. What I'd like you to do, and actually, I wrote the conditions down in the wrong order over there, but so here's a case where a solution's equal to 1, here's a case where a derivative's equal to 1. So what I'd like you to do is discuss with your partner or partners, presumably have solved between the two of you both of those problems. Try to deduce from whatever patterns you see in the numbers that you get, the fractions that you get, what should go here in general. So what's the pattern involved? So what should be your C1 and C2 in these two cases? So see if you can sort that out. It's possible that you might have got an idea already from the example I did earlier. So the idea is you express C1 and C2 in terms of, well, it really just in terms of R1 and R2, because the initial values here are very generic, just 1 or 0. Give that a shot.
I did both one.
If you didn't finish the first part, that's okay. You can continue on that.
I didn't know if you meant for the second one just do 2. The second one just do 1 and 2.
I'm thinking maybe it's R, it's supposed to be 1 over
Well,
R,
it always boils down to this system.
R1 and R2.
So the first
Maybe
case,
that's the only
y
pattern I
will be
see.
1, and then L
Could
is
be a
0.
coincidence, but
And you solve that for C1
our
and
sample
C2.
size is kind of small.
Mine, I got 130 minus 130 for like 0 and 1, and the other one 0.
Each were given right-hand side values.
5
So
thirds, so
in the first
and
case,
negative
1 and
1/3.
0. In the second case, 0 and 1.
These would add up to 1, this would be 0.
Yeah, these add up to 0. I don't know if that, well, I mean, they kind of have to in the initial condition.
Yeah. So first case,
What were your 2 numbers? 5 and
or whatever roots you have,
5 and
R1 and
3,
R2.
where'd they go?
So like in the
Yeah.
first
Okay.
case, you
5
had
and, negative 5 and 3.
Okay, well,
It's 5.
mine
So-
are 5 and 2, and 5 minus
So you
2
just
is
do the algebra
3
and solve it.
zeros. 3 minus negative 5 is 8.
Yeah,
Okay.
So,
I guess they subtract to get the,
there you go. Let's see if the roots were 2 minus negative 4 is 76.
yeah,
How do you get the numerator though?
that's where I didn't. See where you get a 7 out of anywhere in that problem.
So this is all we have to do with these problems?
Yeah, we're focusing on the solving, figuring out how to get C1 and
So
C2.
the stuff that we're doing with the lambda and all of that,
Um,
that's something different or
well, it's part of the same problem, the overall solution process.
so
But
we still have to go through all of that or?
yeah. Well, like you were doing all of that earlier, for whichever problem you picked.
It just is not as long as it took us to.
Okay, I'm not sure what you're asking, but, like,
Like that was like a long process with the lambda and all that. This is like shorter. It doesn't-
yeah, well, can you show me what you did? Because what happened earlier is not really a long process.
That's what I'm saying, it's not as long as it was about the previous days.
Oh, you mean like something that's
Like,
I don't know what you're
like all of
Oh, that, oh, yeah, tough enough because now you're, that's what's the derive the solution formula, and now you just go ahead and use that. Oh, no. Great. That's why I summarized it here. Factor, write down, solve. Nothing more. Wait.
Well, we know how to get the denominator, just not the numerator.
Okay. And that's why I focused on more generic initial conditions. So, in fact, really the easier one to work out as a numerator should be this one.
Yeah.
Because you have a situation where C1 plus C2 equals 0.
Mm-hmm. When C1 basically equals the negative of C2, maybe it's always 1. Like with the coefficient on this equation, how did you solve for C1 or C2 in yours?
I did it like this, where C1 equals negative C2, and then I plugged in negative C2. And found that plugged in the one.
So I was thinking if it was different, like if it was 2C1 equals 3, then 2 thirds might
You
have
are?
something to do with it. But
Okay. Well, let's look at the one that has been worked out. Start with denominators. How do these denominators relate to the roots that we had? Just one.
If it's negative, like there it's
This one
positive
you
four
have
and
C2.
it's negative.
After
It's
plus
positive four and
negative 2.
negative, we add
That's
power.
that's
But
what
in the
that
third
is.
case, I got like R1 is 5 and R2 is 2. So both the
So
powers are positive and we see
Wait, what were your R's for this one?
for that one, I did the third one.
Oh, this one. Okay.
Yeah. So I got R1 is 5 and R2 is 2.
Yeah.
So both are positive and I subtracted it and got 3 in the denominator.
Yes.
that's true for yours too.
But let's return to this case then.
So for here, one is positive and one is negative, and if we add the 2 powers, we get 6.
Or thought the number is, since one of them is 4 and the other is minus 2.
You subtract, and then it's adding.
Yeah, subtract.
But I mean,
Yeah, because if you
okay, yeah, I
subtract,
got it.
Okay.
Yeah.
you subtract negative 5 from 3, you get 8. That's, so we'll write that. Let's get to that.
Okay. So. And that actually applies to both cases, both initial conditions. So if I were to fill that in, just the denominators, it's R1 minus R2. And I was mentioning to someone else, this one actually works out a little more easily than the other because, so for 2 cases, here you're solving C1 plus C2 is 0, and R1 C1 plus R2 C2 is 1. Here we have, no, because that, okay. Yeah, unfortunately I wrote the wrong way earlier, but, okay. Yeah, so, for instance, what does this tell, for this case, what does this tell you about C1 and C2?
C1 is the negative of C2.
Yeah, they're negatives of each other, so you know you have that much. So now you have to make sure that whatever you put as a numerator is going to be negative of each other, that this happens. see, from the numbers that you have for two cases, you can always try solving these directly in terms of generic R1 and R2. Got anything? Anybody?
Oh, yeah.
Okay. Okay. All right. What should the numerators be for this case? What? Yeah, plus or minus 1. So then, because they're negative to each other, this will be satisfied. And then here, you multiply this by R1, multiply this by R2, and you get R1 minus R2 over itself. And then, well, actually, yeah, then you get 1. So here you need, for the other one, you need similar algebraic things to happen just for opposite results. But these have to sum to 1. And then if you multiply this by R1, multiply this by R2, then everything cancels out. But if you work that out, these out for these specific cases, you have the numerators, at least for those specific cases. You have the numbers. How do those numbers relate to your R1 and R2? Because if you have those worked out, the answers are there. They're to be seen.
It's just, number 2 is 8.
Wait, sorry, what?
Isn't what 8? Isn't that what that is? For the bottom one that you have?
Wait, 1 8.
Is that the answer?
Well, yeah. This is a general formula for this case. So for whatever R1 and R2 you have. And then, so the only thing missing is what are the numerators for this case?
-2 and 5.
If you're talking about this problem, yes. Okay, so now, can anyone express that, if arrive at a similar conclusion, what it should be in terms of whatever R1 and R2 you have? So,
C2, -2, 1.
Close. Okay, so, so what you said was, okay, your R1 was 5 and your R2 was 2. And what were your numerators again?
Well, oh, I'm sorry. The numerator for C2 was 5, and the numerator for C1 was -2.
Yeah. So you see what happens. So in terms of general R1 and R2, what should I put here and here? Yes, that's what I'm looking for. Minus R2 up here, R1 up here. Because if you plug in t equals 0, so the exponentials go away, you get R1 minus R2 over itself.
And is that just for those initial conditions?
It's for this one.
Yeah.
And then if you take the derivative, you multiply this by R1, you multiply this by R2. The numerators will cancel out, so the whole thing becomes 0. Okay. All right. Now, for the record, in case you didn't get this far earlier, okay. So for the first problem I gave, y double prime plus 2y prime minus 15 is equal to 0. The solutions that you get are, okay, 5, so y1 of t, that's 1, the solution is 1 derivative 0, is 5/8 e to the 3t plus 3/8 e to the 5t, and then y2 of t. Oh wait, no, that's minus 5. Okay. And then y2 of t, that's equal to 0 at 0, but the derivative is 1, is 1/8 e to the 3t minus 1/8 e to the minus 5t. And then for the other one, y double prime minus 7y prime plus 10y is equal to 0. So your two solutions is okay. All right, so this is y of 0 is 0, y prime of 0 is 1. This is y of 0. No, sorry. Keep doing that. Y of 0 is 0, y prime of 0 is 1. And then for the other one, you get minus 2/3 e to the 5t plus 5/3 e to the 2t. And then y2 of t is 1/3 e to the 5t minus 1/3 e to the 2t. Okay. So the idea was to recognize what are the denominators. They end up being the differences of your two roots. Because here we have 3 minus a minus 5, and then 5 minus 2. For the second solution, where y is 0 but y prime is 1, the numerators turn out to always be 1. For the solution where y is 1 and y prime is 0, you just swap the roots, and then you negate the first one. Okay. Now, as for what I did at the very beginning, that was not these generic initial conditions. These are initial conditions that you guys made up. So general case, general initial conditions, your solution is whatever your y naught is times y1 of t plus whatever your z naught is, your y prime of 0, y2 of t. So this is y of 0 is y naught, y prime of 0 is z naught. So if you were to, so what you could do is you could write down a general formula for whatever initial values you have, where you're multiplying this by y naught and multiplying this by z naught. I'm not going to write it down here. You can actually find it in my notes for section 3.1. But also, you have the information in front of you to come up with it. But now, all right, so that concludes this exercise. But what you can do on your own is see, this is something that's worth doing. If you didn't figure it out before, can you go back and see why it works out that way? Even if you were to make up something else and work it out, see the pattern. Because would I be correct in saying that this is not the sort of thing that you're normally tasked with doing in a class like this? where focus is just on pattern recognition. Because usually you're presented with recipes for solving problems and you just grind them out. But success in mathematics relies on many things, but a big part of that is pattern recognition, being able to see the pattern, to be able to work out problems more efficiently, to open up brain cycles to do more challenging things. Okay, so what I did when I worked out that one was I'd worked these out previously, and then in my head I just grind out, okay, y naught times that one, then plus z naught times that one, for the given values of y naught and z naught that you gave me. Okay. So it's not a magic trick. It's just remembering a pattern that I've worked out before.
You said that's in your notes too, right?
Yeah. So the formula that I would be writing down here, you can find it in my notes. However, what I would encourage you to do is just work it out based on the information here, and then you can have the notes to check against.
Where's, I went looking for the notes the other day, but I couldn't.
Resources page.
Resources.
Yeah, the whole PDF is there, all 100 pages or so. All right. Okay. Now, all right. Again, I'm trying something a little unusual in the interest of giving you a pathway to work out problems more efficiently. So, now, after you've worked out, okay, well, first of all, how many had actually gotten far enough to work these out for whichever problem you chose? Okay, all right, not everybody, but a good chunk of you. Okay, those of you that had, how many were actually able to spot at least some of a pattern? Okay, yeah, I wasn't really sure what to expect as far as whether you'd be able to see that. Maybe it's something that more classes should focus on, because it's in recognizing those things that you can, number one, learn how to solve more difficult problems. And think about differentiation. Okay, you use a power rule all the time. It's second nature. It's actually one of the few things that most students seem to remember. Well, how did that come about in the first place? When people hundreds of years ago figured out rates of change, they might have done it for certain specific powers, and then they recognize a pattern, and now they see how to apply it in general. It didn't start out with having the power rule, and at some point somebody proves it, and then it's taught in calculus classes everywhere. And it's from seeing the patterns in whatever problems you've worked out, and then extrapolating from there, that things happen more efficiently. So if you found that you had the numbers in front of you, but you couldn't really see what to do from there, it's understandable, because and I wanted to confirm or deny this. This is not the sort of thing that you normally would do in a class like this, right? Okay, but that's the point, is to try things a little differently, in case it helps something to stick better, or if it helps you to perform more efficiently on a test. Because as you know, especially for those of you who are math majors, or even some of you who are not, if you do need to take any higher level math, you don't reach a situation where you're still having to grind it out the most laborious way over things from classes or from previous classes, because you're trying to need to be more efficient at what you're learning now to make progress. Okay, so let's see. Well, unfortunately, I've chewed up more time than I wanted. Okay, so does anyone have any comments about this exercise in terms of again, to be honest, aspects that you struggle with? Because again, I'm just throwing you guys to the walls and I have no idea what's going to happen. Anybody? Yeah.
I have a question considering the general sewage and everything.
Okay.
So are you saying that your y naught and your z naught are equal? We shift over to the left to your y1 equation and your y2. Are you saying that they're equal to the negative r2 over r1 minus?
Oh, no. So, okay, if I fill in a little bit more. So what you got there earlier.
Oh,
So,
I didn't realize that. I'm sorry.
Okay, yeah.
I just realized that.
okay. Okay, so any comments about this exercise? Like what? I'm supposed to gather feedback. You're not helping. Okay. Do you think this is something that would, like, having seen how it works out, like, would you? Because you are going to have a problem like this on a test. So, yes,
I understand that there's a pattern and everything.
yeah.
Isn't it just kind of easier to solve it the way we did it a couple days ago?
Where you just grind this out. Is it like, I guess I want to see what you're contrasting with. Up to you. I think that's going to vary from student to student. Because let's suppose you go ahead and work out what that is, the general formula. Some of you are going to have an easier time remembering that than others. But the other thing to keep in mind is, if you do remember it, then you can just grind this out a whole lot faster. But what if you aren't sure that you remember it? You can fall back on this. Redundancy is good. Yes.
So those solutions only work for those initial conditions.
These two, yes. But by combining them with whatever initial values you're given, then you get everything. And that's what I was doing when I wrote this down. So I was taking, so in my head, I was taking 2 times the first solution plus 1 times the second. But I felt that if I just gave you general initial conditions, you'd have a hard time. The pattern is more complex. It'd be very difficult to see. But by breaking down these building blocks, I was thinking you have a better shot at it. And then you can put it back together from there. Yes?
When you said we're gonna be tested on this, do we just do we have to use like the patterns?
No. And then that goes to Julian's question earlier. I don't care what you do, but I do want to give you options. Also, I want to make you aware of, there's a straightforward way for these kind of problems that generally probably doing the homework. I generally show that in examples in class, but it is possible to do even better than that if you want to go that route. So if in this problem on a test, if you work it all out, just write it down, I'll know what you did. And I won't think it's cheating or anything. Yes?
Does problem set 6 focus on this?
Yeah, problem set 6 is on this. Which takes me to my dilemma, is that we're almost out of time, and I meant to spend part of the time on this, and the rest of it finishing up section 3.2, which is a focus on problem 7, set 7, that I handed out. So I'm going to have to push the due date back on that one. So I've officially knocked us behind. I have a few more minutes, 2 more minutes. Okay, so what's going to happen is I don't want to jerk around Dr. Tian and have her change plans, because I just told her she's going to do 3.3. And 3.3 and 3.2 don't relate. So she's going to cover that anyway. And then on Friday, I'll clean up the mess I made today to go back to 3.2 and finish that off. So ignore the due date that I've just given for certainly for problem set 7. Expect an email from me with any changes to due dates, and I'll update the site. So watch for that, and I'll help add some of your attention.